Idempotency. An operation is idempotent if performing it once, or performing it many times in a row, always leaves the system in exactly the same state. It sounds simple. In distributed systems, it's one of the hardest guarantees to actually deliver. You're paying for a flight. You click pay. The page hangs. No confirmation, no error, nothing. So you click pay again. 10 seconds later, 2 charges, 1 seat. The button doesn't know it already fired once. And on an unreliable network, clicking twice isn't a mistake. It's the default behavior you have to design for. Networks don't just lose requests, they lose responses too. A server can finish the job perfectly and never get to say so. From the client side, a slow success and a total failure look identical. Silence. So retrying isn't reckless, it's the only safe move. The real question is, what happens when that retry lands twice? The fix starts on the client. Before sending a request, generate one unique key, a UUID, for that logical operation, and attach it to every attempt of it. Click once, the key goes out once. Click 3 times by accident, and all 3 attempts carry that exact same key. On the server, every incoming key gets checked against a ledger. The first time this key shows up, there's no match, so the server does the work once and stores the result right next to the key. The second attempt arrives with the same key. This time it's already there. Instead of charging the card again, the server just returns what it already wrote. The third attempt gets the exact same treatment, no new work, no new charge. Just the same answer handed back instantly. But what if 2 identical requests arrive at almost the exact same instant? Whoever gets there first has to win outright. A unique constraint in the database, or a distributed lock, makes sure only one of them is allowed to write. The other one doesn't retry the work. It simply waits, then reads the result the winner already produced. Not every operation needs this trick. By definition, get, put, and delete are already idempotent. Send the same put 10 times, and the resource ends up in the exact same state. Post is different. By design, it creates something new every time it runs. Send the same order request 3 times, and you get 3 orders. That gap is exactly why idempotency keys exist, to make post behave like it's safe to retry. This shows up constantly in message queues. Systems like Kafka and SQS guarantee at least once delivery. If there's any doubt a message was processed, they'll simply redeliver it rather than risk losing it. That means your consumer will see duplicates. It's not a bug, it's the design. Pair that at least once delivery with an idempotent consumer, and the two together give you something that behaves like exactly once processing without ever needing to guarantee it directly. Idempotency doesn't stop retries from happening. Networks will always fail, and clients will always try again. What it changes is the outcome of that retry. Same key in, same result out every single time, whether it arrives once or 5 times. If you enjoyed this video, please like it, comment below, subscribe to the channel, and tap the bell icon so you don't miss the next one.